All right, hi everyone. Thanks for coming. My name is Alexey Savadyev. I'm a Senior Program Manager for Azure Cosmos DB, and today I'm going to tell you all about it. I'm going to give you an overview of various capabilities that the product supports. Now, what is Azure Cosmos DB? We position it as a globally distributed multimodal database as a service by Microsoft. We support multiple APIs, that is multiple ways to write and read your data. We support multiple models, and we operate on top of Azure infrastructure. We are Ring 0 Azure service. That means that we are in every single Azure region, 42 currently. That's more than Amazon and Google combined. Whenever the new region gets added, Cosmos DB will be there by default. So underneath the covers, on top of this Azure infrastructure, what we've built is called ARS, Atom Record Sequence schema. This schema essentially holds all the data, and that data is represented in multiple data models that we currently support, which is key value pair, column family, document, and graph. And these models are covered currently by 5 APIs that you see here on the screen. Table API essentially covers key value pair data model. It used to be called Azure Table Storage. Now it's folded into Azure Cosmos DB family. And Cassandra API that covers column family data model. And SQL API and MongoDB API cover document data model. They store the data in JSON documents. And Gremlin covers the graph data model. Why this is important is because those APIs are ultimately going to be interoperable. That is, you will be able to write the data with one of them and read the data with any other. Currently, SQL API and Gremlin API are interoperable, so you can write the data with SQL and read it with Gremlin in the form of a graph. Visualize it for your users. Now, what we provide underneath, using all this infrastructure, all the services that we've built, is turnkey global distribution. That is, you can come to Azure portal, deploy your data, and within a click of a button, distribute it across the globe to all 42 regions if you want, or just to 1 or 2, depending on how many regions you need to cover for your users. Why this is important is because users can be anywhere, and in order for them to get the lowest latency and the highest throughput, you need to deploy the data near wherever your users are, right? And Cosmos DB provides you that capability. Essentially, all of your data can be made globally distributed, or it can be simply hosted in one particular region. We provide elastic scale-out of throughput and storage independently. And this is important because sometimes you need a lot of throughput, for example, for notification applications that notify a lot of users at once, but they don't need to have a lot of storage. So you can have that here. Or you can have an application that requires to store a lot of data, like archival applications or document management applications, but they barely have any users, and you don't want to pay for a lot of throughput, therefore. So you can have that too here. Some of our competition actually does not provide these capabilities because they simply deploy the data in the virtual machines. And therefore, you're limited to the configuration of actual virtual machine. If you have some throughput, you will have some storage too. If you have some storage, you will have some throughput. And you pay for all of that. In Cosmos DB, those two things are completely independent of each other. We provide you guaranteed low latency of less than 10 milliseconds for a 1 kilobyte document read, and less than 15 milliseconds for 1 kilobyte document write. Therefore, if you increase the sizes of the documents, the latencies will grow. But this is the benchmark that we actually subscribe for, and we give you the SLA on these latencies out of any of the regions that we support. We also have other SLAs. For example, there's SLA on consistency. We provide you 5 well-defined consistency models It's 3 more than typical, eventual, and strong consistency. In fact, what we found is that users typically choose session consistency because it's the easiest one to use. Session consistency is similar to strong, but within a confines of a single session. If you have a data access layer that connects to the database, it will be a single session. If you have a device that connects to Cosmos DB, it will be a single session. So it actually makes sense to provide session consistency in most cases, and not strong, because strong is super expensive. It needs to replicate the data before the data becomes available for reads. The other 2 that we support are bounded staleness. It's something in between strong and session. Essentially, it gives you strong consistency, but within a certain period of time or certain number of updates of the data. So certain interval of time defined by you, or certain number of updates or prefixes, as we call them, defined by you on the portal. Also, we support consistent prefix consistency model, which is essentially similar to eventual, but at least it gives you the ability to write and read the data in predefined order. Your reads will never be out of order compared to your writes. With eventual, anything goes, and you can read the data in any particular order whenever it becomes available. Now, we also provide SLAs in addition to the ones that I've mentioned on high availability, which is 4 nines of availability out of a single region, 5 nines if you actually increase the number of regions. With the second region, we're already able to provide 5 nines of availability. That's literally just a few minutes of downtime within a year that we allow the service to be down. If it goes above that, then you can simply demand your money back. And we actually do return the money back in case any of these SLAs are broken. And also there's an SLA on throughput. Throughput is something that you pay for, therefore we do provide you SLA that within the provisioned throughput that you have, you will definitely have it every single second when your service operates. And if it goes below that and you see that you're being throttled, again, you can demand the money back on that. Now, we handle any kind of data. This is a NoSQL database, right? It's not relational. Even though we have SQL API, we allow you to specify your documents or the format of the documents when you write them in whatever shape and form. You can mix and match them in your collections. You can infer the schema on a read if you like. But we don't mandate any particular schema. Therefore, it's super fast to ingest the data. You can mix and match them in small number of collections, and you can read them as you please, and you can infer the data on the read. Now, we also provide very comprehensive security. We encrypt the data at rest and in flight. In flight, it's encrypted with TLS 1.2. At rest, it's encrypted with the key that we generate upon creation of your account. And we'll soon be able to provide you the bring your own key capability as well, if you want to encrypt it with your own key. We also provide a number of certifications. We're PCI HIPAA compliant, SOC Type 1 and Type 2, European Union model clauses. It's a pretty large and comprehensive set of compliance certifications that we have. Now, let me give you one example. This is an example of the architecture that Next Games, a Finnish gaming company, uses for the game called Walking Dead, No Man's Land. Cosmos DB here is used as a single database for a bunch of application servers that they run, web services essentially, that they run in different regions. It automatically load balances itself. You only have to deploy it once. If you want to increase the number of regions, you can do that, but you don't have to. It will, essentially, your clients that read the data from Cosmos DB will determine what is the nearest location for the regions where your data resides, right? And Azure Traffic Manager here is only shown because there needs to be some sort of traffic management happening before the application servers. Application servers do not have to be separated from the database by some sort of a load balancer or traffic manager. Cosmos DB takes care of that. Another pattern that NextGame uses is the ability to store the data that is super important, the user data, the main game data set in Cosmos DB, while other things like textures, videos, images are stored in very cheap blob storage. And that can be stored through Azure CDN. Cosmos DB doesn't need its own CDN. It's actually a CDN of its own for the data, right? And then you can use the integration with HD Insight, which is Microsoft's implementation of Hadoop. It's a Hortonworks distribution that Microsoft adopted for Azure. And you can also use Azure Functions to create your own serverless applications based on your database. So whenever something changes in the database, it can trigger Azure function in which you can describe your application's logic. So you don't have to deploy additional VMs. We have the integration for Azure Functions available. We also have integration with Spark available as well if you want to distribute your application logic through Spark worker nodes that can reside next to Cosmos DB. So in this particular example, they use Azure Functions to call the Azure Notification Hub to notify the users that something happened in the game. One of their friends signed up, or they got signed off, or something happened with the game itself. For example, certain event happened within the game, and they get notified if they don't necessarily watch the game screen. So Azure Notification Hub provides you integration with iOS and Android push mechanisms. That is all I have. Any questions? No? All good? Thanks for coming. Thank you very much.